All right, today we're going to dive into the world of a chemical that's, well, it's truly fascinating. It's notoriously dangerous, but it's also, strangely, a chemist's absolute favorite. This is the story of making a liquid carcinogen, chromyl chloride.
You know, this quote really sets the stage. It comes from the chemist at the center of all this. Imagine, after working with hundreds and hundreds of different chemicals, just one really stood out from all the others. And trust me, it's not the one you'd expect.
And that's the million-dollar question, isn't it? I mean, this stuff is toxic, it's corrosive, and yeah, it's carcinogenic. So what on earth makes chromyl chloride so captivating? Let's get into it.
Okay, so let's try to understand the appeal here. What is it about this particular chemical that makes it so special to someone who works with it? So here are the so-called fun properties. And it's a wild list, right? On one hand, you've got this whole laundry list of terrifying hazards. But on the other, it fumes like crazy, it's super volatile, and it has this absolutely stunning, deep, blood-red color that makes it just mesmerizing to work with. It's that dance between danger and beauty that really pulls you in.
Now, to put that danger into perspective, we're not talking about something harmless like table salt, but it's not exactly a chemical weapon like sarin gas either. A 5 on this scale means you have to have some serious respect for it. You need to handle it carefully. But it's not so crazy hazardous that it's just pure fear to work with. It's manageable, but it definitely keeps you on your toes.
So how do you actually make this stuff? It's not like you can just order it easily. The whole process takes incredible precision, starting right from the very beginning with the ingredients. All right, so these are your three main components. You start with potassium dichromate. That's where the chromium comes from. Then you need sodium chloride, and you want to use pure pickling salt here to make sure there are no weird additives like iodine getting in the way. And finally, the thing that kicks the whole reaction off, really, really cold, concentrated sulfuric acid. You know, the secret to this whole synthesis, the thing that makes or breaks it, is how well you mix those first two solid ingredients. They have to be ground into an incredibly fine, totally uniform powder. A previous attempt using a mortar and pestle, well, the results were just okay. This time, a simple electric blender is used to get a much, much better mix. The setup in the lab has to be just right. So the powder goes into a big flask, you attach something called an addition funnel on top, which lets you add the sulfuric acid super slowly, and then a condenser is set up to catch the final product. And pre-chilling that acid is absolutely critical. This reaction generates a ton of heat, and you do not want it getting out of control. And now for the best part, the most visually incredible part of the whole process, the distillation. This is where the pure, blood-red chromyl chloride is finally born. So once all the acid is added, the whole mixture gets gently heated. The chromium chloride, which boils at about 117 degrees Celsius, starts turning into this vibrant red vapor. The vapor travels up and into a water-cooled condenser, which cools it back down into a liquid, and it drips, looking exactly like drops of blood, into the collection flask. It's an amazing sight. The stuff you collect isn't perfectly pure right away. You get some solid chunks in there, probably from the chemical reacting with tiny bits of moisture in the air. The easiest way to deal with this? Just let it sit overnight. The solids sink to the bottom, and the next day, you just carefully filter the liquid through some glass wool. Simple, but effective. And the final yield? Get this, a whopping 67%. That was way, way better than expected. And it's a huge improvement over past tries, all thanks to one really simple change. This chart really drives the point home. You can see just how important that mixing step was. The old way, with the mortar and pestle, only got a 52% yield. But by using a cheap kitchen blender to get a finer powder, the reaction was nearly 30% more efficient. A simple fix with a massive payoff. Okay, so we've made the stuff. Now for the really fun part. Let's see what it can actually do. It's time to put it to the test and explore some of its unique and sometimes fiery properties. You know, at first glance, you might mistake chromium chloride for bromine. They're both fuming, dark red liquids. But side by side, whoa, they're super different. The chromium chloride is a much more vibrant red, and it has this weird habit of creeping up the sides of the glass. Bromine is darker, almost black, and its heavy vapor just sinks, completely different from the lighter fumes of chromium chloride.
Okay, this is one of the strangest things it does. Chromyl chloride is almost twice as dense as water, so when you drop it in, it sinks right to the bottom. But it also reacts with the water, creating bubbles of hydrogen chloride gas. These bubbles stick to the droplets, making them buoyant enough to float back up to the surface. So they sink, then float, then sink again. It looks like they're dancing around in this weird self-propelled motion.
Now, a lot of its most jaw-dropping reactions have a special name, hypergolic. That just means that when you mix certain substances, they burst into flame the instant they touch, no spark or heat source needed. And since chromyl chloride is a crazy powerful oxidizer, well, you can probably guess what's coming next.
First up, ethanol. The second a drop of chromyl chloride touches it, bam, instant fire. The ethanol gets oxidized so incredibly fast that it generates enough heat to just ignite on its own. A perfect and really dramatic hypergolic reaction.
Next is aniline, which was actually a component in some early rocket fuels. The reaction here is a little more tame. There's this noticeable delay, a pause, and then it ignites. It's still really powerful, but it just goes to show how different fuels can react with the very same oxidizer.
But this might be the most incredible transformation of them all. It's called the Etard reaction. It uses chromyl chloride to perform a sort of gentle oxidation on a chemical like toluene, which is basically just paint thinner, and turns it into benzaldehyde. And what's benzaldehyde? It's the compound that gives us the smell of artificial cherry and almond flavoring. From a toxic solvent to a pleasant smell. Just amazing.
So after making this stuff and seeing everything it can do, there's one last challenge. How in the world do you store something so corrosive and volatile that it wants to eat through or leak out of pretty much everything?
The only really foolproof way is to seal it in glass. For good. This means you have to make a custom ampule, carefully heating a test tube and stretching it out to create a thin neck. Once the chromyl chloride is poured in, you take a blowtorch and melt that thin glass neck shut, creating a perfect, permanent seal. A final tip, upside down, make sure there are absolutely no microscopic leaks.
And that really brings us back to the beginning, doesn't it? From its fiery, explosive reactions to its incredible ability to turn paint thinner into cherry flavoring, chromyl chloride is a chemical of stunning contrasts. It kind of forces you to ask, what is it about the difficult, the dangerous, the beautiful, that drives that scientific curiosity? What makes a substance like this worth all the risk and trouble to explore?